another problem that I'm going to give you is this particular problem used to come many times in the examination. A car hire firm has two cars which it hires out day by day. Okay, the number of demands for a car on each day is distributed as a Poisson distribution. Now you see in this particular problem, they have already mentioned you that they have judged the system and the system is behaving in a Poisson way. So don't have to judge the system by yourself. You have to only apply the methodology of Poisson probability law to the given problem. In the previous session, I talked about a situation where you had to judge the system whether it is indeed Poisson or not. But here it has already been mentioned. People used to set this type of questions in the examination. Okay, where you have to think less. With mean 1.5, calculate the proportion of days, Yeah, proportion, by what the proportion I actually mean the probability. These are equivalent words. If I say 0.25 is the probability, with respect to the proportion means out of 100 it is 25. Okay, so proportion of days on which neither car is used, and number two, the proportion of days on which some demand is refused. Now you see that I'll ask all of you to do the probability problems, this type of questions, the applied statistical questions. First of all, you have to understand that why it is important. See, because every problem comes out of a situation. Here we are doing the problem means we are judging the situation. Okay, so situation is actually very important. To every problem, how ridiculous it may seem to you, but every problem has come out of a situation and with some objective in mind of the experimenter. Experimenter had find some sort of objective in his mind, so he set this particular type of questions. He has done many things for you. In every question that this question is in front of you, underlying thing is that there was a huge data. Everything is about data analysis. So there was a huge data on the basis of which he has declared that his system is behaving in a Poisson way. Mean he has calculated, which is 1.5. He calculated the Poisson mean by the formula of the mean. By formula of the mean is expectation of x equal to xpx. That is the mean formula. So he has calculated the thing for which he needs. What is the mean formula? Try to understand this particular part. Nobody will tell this to you, or in book it is not written. The mean formula is expectation of capital X, which is x into probability of x equal to small x. Now, whenever he is calculating the probability, the mean of this Poisson variate, that means what? He is saying that he is actually calculating, he is taking all the values and he is putting this particular thing, e to the power minus lambda to the power x by x factorial. and he is calculating the value somehow, and it is coming out to be lambda. Okay, now somehow this will be told to you later in module 4, not right now, but he has done this kind of calculation for you already, and he has declared that it is 1.5. And not only this, whenever he is taking this kind of he is calculating this kind of expectation, he needs values, not only one or two value, he needs huge number of values on the basis of which he is calculating that. A huge number of values will be, first of all, he has mathematically established thing somehow, and then he is, but once he knows that okay, in this type of situations this is bound to come, then he is actually getting the value, but data is required. So this data type of thing, the data collection type of thing, analyzing the data, how it is behaving, this you are free of the you have been freed from this, doing this hard jobs. But in practical field, whenever you are going to analyze the situation, this part, this paragraph is means something to you. This is not negligible, it means something to us. We have to perform this part also before we find other parts. Question number 1 and question number 2 means something. So this is the thing which practically, if we could have time, we could have given you a situation, and I could have asked you, okay, then analyze this situation and try to find out the underlying probability distribution. So for example, in the previous session, I told you that a probability distribution for COVID-19 virus has not been established yet. So it is an open problem for which you need to have some kind of data. Okay, you have to analyze all the existing probability distribution. If none is satisfying, then what you can do, you can think of how can you establish the probability distribution. So this is a matter of research scientists who do research works on probability measure theory. They try to do this kind of thing. But anyways, since most of the things of the problem are cooked up, we are going to apply the probability distribution as demanded from the question by applying the Poisson law. Obviously, to start with, we see that here in this particular problem, our random variable x is actually the number of demands for a card. This is my random variable over here. Okay, and this x is actually following Poisson distribution. Here P stands for Poisson. I'm using this sign for denoting Poisson. P stands for Poisson with parameter lambda, which is 1.5. So this is known to me, and since it is known to me, probability of x equal to small x, that is probability that there is x demand, okay, is given by the formula e to the power minus lambda to the power x by x factorial. X is equal to 0, 1, 2, and it goes on. So we know these facts. Now, when there are many car hire firms in the city, okay, and it's a very symplectic situation that they have considered. A car hire firm has only 2 cars. No car hire firm has 2 cars. Okay, it cannot be. Car hire firm can have many cars. It is not 2 cars. So they have made the situation symplectic. What is the motivation of doing this particular problem? Motivation is that whether you are able to apply the Poisson probability law or not, whether you understand what do you mean by neither card is used, whether you understand by the fact that some demand is refused. They are judging your technical skill by giving you this sort of problem. Your analytical skill is not being judged. In problem, what we judge the 2 types of things for the people. We try to, you can judge the analytical skill of the people. We can find technical skill of the people. Analytical means your analytical thinking. And technical thing means whether you are able to apply the formula or not, whether you can understand the parts or not. Okay, so here by this particular problem, your technical skill is being judged. My x is the random variable which gives you the number of demands for a card. So if I want to do that part one of the problem, probability that neither car is used. That means the car hire firm has two cars, no car has been used for a certain day. So obviously the demand is zero. So they are asking you to find out that what is the probability that demand will be zero on a certain day. Neither car is used. Neither car is used means the demand, number of demands for the car is zero. And it is quite obvious. It is e to the power minus lambda, lambda to the power 0 by 0 factorial. And e to the power minus lambda means e to the power minus 1.5. I am keeping it for you to calculate. Calculation is not required. Calculation skill is not being tested over here. Second is some demand is refused. Now you have to understand this particular fact that when for this car hire firm the demand will be refused. The thing is that the demand will be refused when, because he has two cars, the limit of the cars which can be demanded from this car hire firm is only 2. So since he has two cars, demand will be refused if the number of demands exceed 2. Otherwise the demand will not be refused. So actually this this is what they mean for by to find out what is the probability that some demand is refused. This is the meaning of this. Okay, because x must be greater than or equal to 2, otherwise demand will not be refused. Again, you don't have to consider in any infinite series. If your capital A is x greater than 2, your A complement will be x less than or equal to 2. So you are relieved of calculating any big calculation with infinite series. So you can write it as 1 minus probability of x less than or equal to 2. And whenever you are writing 1 minus probability of x less than or equal to 2, then I'm writing in the next page. Then it means that I'm writing it over here. Probability of x greater than 2 is 1 minus probability of x less than or equal to 2. It means that you are going to calculate these probabilities. Probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2. And you are going to, rest is a technical skill. You are going to put these values over here. E to the power minus lambda, lambda to the power 1 by 1 factorial plus e to the power minus lambda, lambda squared by 2 factorial. That's it. And you can perform the mathematics. You can take lambda 1 minus e to the power minus lambda to be common, and you can write it as 1 plus lambda square. And lastly, you can put the value of lambda e to the power minus 1.5, and you can write it as 1 plus 1.5 plus 1.5 whole square. I am leaving it for you to calculate and find the value. And then you express the value in terms of percentage. You will get the proportion of days, find out the value. Okay. So this is how we can do, we can find the particular problem in this type of scenario. Okay. So, and you see that this particular problem, oh, one thing that I actually came to my mind while solving the problem. Remember this thing, that in inequality type of thing, if suppose I'm writing x greater than a, if this is your event, remember this, and x is discrete over here. It's very important fact, you have to keep it in mind. I'm considering the x to be discrete, not continuous. Then if b is equal to a bar, this will be x less than or equal to a. So equality sign is not there in the event a, so it will be present in the event a bar. But suppose your event a is x greater than or equal to a, then your b event will be a bar, which is x less than a. Equality cannot be placed in both the situations, in a and a bar. If you put, say for example here, if you are not cautious enough, and if you write x less than 2, if you write that probability of x greater than 2 is actually 1 minus probability of x less than 2, then it is a mistake. It is wrong. Remember that X is discrete. I'm again saying, I'm considering the discrete case. In continuous case, the scenario will change. So it is a mistake. If you write so, this value will be missing and probability will change. It will not reflect the situation properly. So you have to be very careful about this particular situation, scenario. Some relevant parts that I'm actually telling you, and you have to keep this in mind. No, minus, someone has written that the minus value will come. You have done a mistake, minus value will not come. Please, others, please check that whether someone has given me a direct message that minus value is coming. Minus value will not come. Probably he has done a mistake. Others, please do calculate this quantity and tell me what value is coming. Minus will not come. There is some sort of mistake in your calculation. Oh, one thing. I missed this point. No? Your calculation is not wrong. This part, 2 factorial, I have not written. 2 factorial part was missing, therefore probably minus is coming. 2 factorial, put this value 2 factorial. Here 1 factorial is there, 0 factorial is there, 2 factorial is there. Probably now the minus will not come. Just check and tell me in a direct message. So see, I am also error prone. Okay, so doing errors is actually not a shameful thing. Errors help us to learn things in a better way. So the person who is calculating the thing, please recalculate and tell me in a direct message that now it's all right. Now, another problem that I'm going to give you is, suppose that the number of telephone calls coming into a telephone exchange, it has become actually a kind of scenario for old days. Okay, he has got the right answer now. It's the old days, because nowadays telephone exchange kind of thing is actually not there. Everything is done through, we get every system through satellite. Okay, so this scenario, what I am writing, is not in vogue, not in fashion, but still I am doing it because the time at which the book was written, in those days, this particular problem was very much in concern. Okay, so therefore, to our current situation, this problem is an obsolete problem. Anyways, this problem will help us to learn something else about this Poisson probability. Okay, so for this extra knowledge that I'm going to gather from this particular problem, I'm selecting this problem. Its practicality is missing, but some kind of information, mathematical information, that I'm going to gather from this particular type of problem. So let me write down this problem to you first of all. This will be my last problem of today's class, don't worry. If these are independent, what is the probability that more than 5 calls come in between 10 a.m. and 12 noon. Calculation anybody can do. Anybody who has understood the problem can do the calculation, but I'll analyze the situation first. First of all, we don't have to think about whether the situation is behaving Poisson way or not. Poisson distribution is actually being followed over here. Definitely they have mentioned. So we have to abide by that. Probably they have studied the system and have got the data and calculated this, observed this kind of things. So this is a kind of uh, their declaration that it is behaving in a Poisson manner. Important part is that here in this particular case, two random variables are associated. One is x1 and another is x2. Why two random variables are associated? Because two time frames have been set over here. One time frame is 10 a.m. to 11 a.m. Another time frame is 11 a.m. to 12 noon. So in these two time frames, the calls are the variable is actually following Poisson distribution. If suppose it may so happen that suppose try to think about the situation. Suppose it is a normal day. It is a normal day, and telephone exchange is receiving calls in this particular manner, in a Poisson way. Nobody knows that at what time a particular person is going to call someone, because in the previous days, there we didn't have a mobile phone with us, and to call someone, we need to put coins. We have to go to the PCO, and before that, many few people used to have the old sort of telephone in their at their home. So telephone exchange was not sure about how many calls will be received for by in a particular time. So that's why they are saying that the situation is behaving in a Poisson manner. Whenever they are saying that it is following the first for the first time frame, the variable is following. The variable is actually the number of calls received. Your capital X1 and capital X2 both are random variables giving you the number of calls received. So whenever they are saying that x2 is 2, parameter is 2, that means on an average, they are receiving 2 calls from 10 a.m. to 11 a.m. And on an average, they are receiving 6 calls from 10 a.m. to 11 a.m. to 12 noon. So two types of parameters are there. Now, suppose it is a war time. Some kind of Second World War is going on. So in the telephone exchange, the number of calls received may not be Poisson. Then many calls are coming to the telephone exchange. The soldiers have gone to fight, and they are trying to contact or communicate, or many sort of diplomatic messages, and they are being transferred from one particular state to another particular state. So it may so happen that for certain period from 10 a.m. to 11 a.m. x1 is Poisson, and for 11 a.m. to 12 noon, x2 has suddenly become exponential growth in receiving the number of calls. It may also happen. So, but in this situation, they are saying that it's a normal day. It's a very sunny and bright day, and therefore things are behaving in a Poisson manner. So how to find out that how to find out the probability that there will be more than 5 calls receiving between this particular time frame. So previously, this is the time frame 1, and this is the time frame 2. Okay, but here the time frame has been added with one another. So time frame 1 and time frame 2 has been added with one another. Okay, so we have to judge the situation. So let me quickly judge the situation because time is running out. So in this situation, capital X1 as given, capital X1 is the number of calls received by the telephone exchange. Okay, X2 is also the number of calls received by the telephone exchange. And it is from 10 a.m. to 11 a.m. And this is for 11 a.m. to 12 noon. And here X1 is giving satisfying the Poisson probability law with parameter 2, and here it is satisfying the Poisson probability law with parameter 6. We are supposed to find the probability for this random variable. This is the total number of calls received between 10 a.m. to 12 noon. Okay, so time frame has been merged. This is your capital S. Only thing is to know how S will behave and what will be its probability distribution. So I was telling you that you are going to learn a mathematical knowledge from this particular problem. The knowledge is as follows. If x1 and x2 are Poisson, okay, then x1 plus x2, the sum of the two random variable, is also Poisson. So at least we know that my capital S is a Poisson variant. Okay, this is my knowledge number 1. So I'm writing here 1. And knowledge number 2 is as follows, that if x1 is Poisson and x2 is Poisson, and x1 and x2 are independent, as it is mentioned in the problem, then x1 plus x2 will be Poisson. Suppose it is a Poisson with some parameter lambda 1. Let me write in a different color. Suppose it is a Poisson with parameter lambda 1, and this is Poisson with parameter lambda 2. And see if x1 and x2 are independent. This is very important formula or theorem. Then x1 and x2 will be Poisson, and x1 plus x2 will follow Poisson distribution with parameter lambda 1 plus lambda 2. Their parameters will also get added. This is a very important fact. If you do not know this particular fact, you will not be able to prove this theorem, solve this particular problem. So with the knowledge of this fact, we can say that if S is my x1 plus x2 and number of calls received in two time frames are independent of one another, so by this particular rule, we can say that S will follow Poisson distribution with parameter 2 plus 6. That is, S will follow Poisson distribution with parameter 8. This is the important knowledge. Rest is just a matter of calculation, matter of time to calculate the things. So you can now quickly calculate the remaining part. The question is, what is the probability that more than 1 calls will be received, more than 5 calls will be received between this joint time frame? So since S is following probability of Poisson distribution is probability 8, so probability Poisson distribution that capital S will have some value is given by e to the power minus 8 to the power x, 8 to the power, 8 to the power x by x factorial, and x is running from 0, 1 to up to infinity. And we are interested in finding the probability that more than 5 calls is received. So S greater than or equal to more than 5 calls. So S greater than 5, not greater than or equal to, will be there. So we are interested in finding this particular fact. And by complementary probability, we can write it as probability of S less than or equal to 5. Now what you can do, you don't have to calculate the entire thing. You can write it in the following manner. What you can do, you know that it is nothing but probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2 plus probability of x equal to 3 plus probability of x equal to 4 plus probability of x equal to 5. So what you can do, you can simply write 1 minus summation x grows from 0 to 5 e to the power minus 8 to the power x by x factorial. Rest is just a matter of calculation to find this particular probability. Nowadays, this sort of calculation is not done manually. Many mathematical softwares are there. Don't worry, that I'll show you the mathematical softwares someday and how to do the statistical calculation using mathematical software will be shown to you. You just have to have some kind of patience, and you have to patiently hear me about what I'm saying. Anyways, there are many more problems. I'll also send you a note. One note has already been sent to you earlier on the first part of ours, on the basis of independent event axiomatic approach and conditional probability. I will send you the second part of the note. You have to give me some time. I'm preparing the note, and many problems are there. Now it is up to you to test your analytical and mathematical skill to do the problems. So whenever you face any difficulties, you can contact me. You can write direct message to me. I'll respond. Okay. So with this, I'm going to end my today's session. Again, thank you for joining on holiday to attend my class. I do not know whether I'm able to satisfy your demand or not. But anyways, thank you again. And on Friday, I'm going to take the examination, and syllabus has already been mentioned in the WhatsApp group. Time and the way of taking the examination, everything will be discussed with the class representative, and your situation will be taken care of. Don't worry. So with this, I'm going to end my today's session. See you soon. See you next week. Till then, bye.